Hi, everybody. We're going to go ahead and get started here. So thank you all for joining us. I want to make a couple of quick announcements before we get going. First one is this is being recorded, so be aware if you miss something, you have to go hop on a call. We don't know how work goes, whatever it may be. It will be available on our YouTube channel a couple of days afterwards. It also just takes us a few to get it edited and put up. Also, we will be taking questions. Please, if you have something that pops to mind you want to ask, go ahead, add it to the chat box, send me a message with it. Once we get to the end, I will go through any questions we have. There will also be a chance there if you want to add them in, but just make sure you don't forget about them during the presentation. And without further ado, we're going to get started. So welcome. Again, this is Advanced Data Tools. This is Tom Beebe speaking. Going to cover the basics of Connection Manager. So this is part of our best practices series, and we felt that Connection Manager has really become a best practice when using any kind of replication with Informix, and even when not. And we felt it really worked well with the series of trying to get everybody working on what we personally view as some of the best practices with Informix. So thank you for joining us, and going to get going. There we go. So this talk I've given a couple of times now, but I've revamped it each time. It started out, I put it together as a guide for myself when starting to work with Connection Manager. The documentation online that IBM's put out is not entirely comprehensive and was not that easy to parse out everything that was needed to actually get going with it. They have some examples up, but it's a little limited. So I wanted to kind of detail all of the options, all of the settings, and go through what you actually need to do from, from complete bedrock up to having a fully working Connection Manager environment. I also noticed that there are some things that are a little confusing getting going. I wanted to make sure we highlight those, just so when you hopefully go back to your work environment and either set up Connection Manager or work on it, everything will make a little more sense. I have gotten input from a number of other people that are actively using Connection Manager, putting this together. If you have things that you've come across that you think are really neat or I should add in, please drop me a note with them. I am always improving these sort of talks, so the more feedback I get from other people and using the tool, the better. So what is Connection Manager? It is a standalone program that IBM introduced into the Informix product with 11.5. It was heavily revamped in 11.7 and basically fine-tuned in version 12. It'll work with actually any version you are running because it is actually shipped with the Informix CSDK as well. So you can actually install the CSDK and use the Connection Manager in there. The big advantage of having it as a separate piece means you can have a separate upgrade path, separate installation base, etc. It is also a free utility. You do not have to have a separate license for it. However, if you're running it as a standalone CSDK, and running it in production, you probably want to look at getting the support license with your CSDK just so you get that support level. It can be used as a central broker for connections to have a central point where all of your different types of connections that you may have are managed. It can also be run as a cluster of connection managers acting as the front-facing point of your database connections. There's many ways to run it. We'll go through a number of times. Just got a note saying, did it start? Lester, is it working for you? Sorry, someone added a note asking if it started. I'm getting confirmation it is in fact streaming correctly.
Yeah, it works, Tom.
Okay, just checking.
I did see a note that it wasn't working though.
So okay, just making sure. So again, it can be run solo. You can have series of them playing nicely together. Originally intended for high availability, can also be used for disaster recovery, or can just be used for simplifying connections from your application layer. There is an OAT module that will help monitor Connection Manager, so that's out there as well. We're not going to focus on the OAT piece in this talk, but I just wanted to mention it is there. So topology, how does it actually work? Why do we care? Your standard topology is you have your client applications, whether it's an individual, whether it's a web application, whatever it is, it comes in, it connects to your Informix system. What Connection Manager does is it sets a layer in between your client and your servers. And so what it actually will do is we'll take, the clients will connect to your Connection Manager, and then your rules of your Connection Manager will tell it where should that connection go. Are we going to a primary group? Are we going to our secondary group? Are we going to a read-only group? Are we going always to the updatable section? Are we going to the fastest node? Whatever your rules may be, Connection Manager will do that. What it also means is for the application developers out there, you can set up your connections to have your ODBC or JDBC or whatever kind of connection point to your Connection Manager. This means your applications don't care where your database server is. You can change the database server's IP address, the server name, the ports, whatever else you may need to do with your network, and you don't need to go back and change your 5,000 different client connections. All you have to do is update your Connection Manager to tell it where it's going to be pointing. So, setting up access. So we're going to cover a little high-level ground here on it, and then we're going to dig into all the different configurations and configuration settings. So to actually set it up, the simplest way is to just have it be a middleman. So your client connects to your Connection Manager goes to your instance and tells the two to talk together. So it's just one instance, one client, Connection Manager sits in the middle. This can be useful if you want to not have to worry if you change your instance, IP address, or port, or something else. It can also be useful if you're using the Connection Manager in a DMZ environment. So your Connection Manager is the only part that can actually talk directly to the database, and your clients then connect in the Connection Manager. It can also be set up as against a replication set, so your client connects to your Connection Manager, and the Connection Manager will go through, and depending on the rule, connect to your primary server, your secondary, your RSS, SDS, whatever it might be. It'll go through and follow the rules. You can set up with multiple groups. So maybe you have your in-house data warehouse that you've got your primary and your secondary. But then you have a second group, which is maybe an ER cluster that you've got 5 or 6 nodes remotely. And then you have a third, accounting standalone server. You can use the same Connection Manager and have different rules and different groups for each of these different areas of your environment. So it's a very flexible system without needing to run multiple copies. So the clients will actually connect to a listener that the Connection Manager spins up. The clients just think this is a normal Informix listener, so it doesn't know that it's talking to the Connection Manager by default. And then the Connection Manager will figure out the rules and send the data along. It's actually very lightweight. It's very quick. Really, your clients should not notice a difference if there's not a latency issue somewhere in the pipeline there. You can also, the default way to handle a Connection Manager, and I mentioned the trust here because we're going to have to discuss it in depth a little bit later on. By default, we'll use standard trust, at least for our examples. We're going to be using standard rhost methodology, so it's going to be rhost in the user directory, same as trusting Informix otherwise. But you can also use the other Informix trusted methodologies, such as host equiv, or having an encrypted trusted password system. There's a number of ways to do it, but just when you're thinking about how to actually set up access, that is one consideration, is how do I have my Informix server trust my Connection Manager server? So relevant files. The first one is our SQLHOSTS file. This is obviously one of our key pieces. Just like for Informix, it controls the listeners and the ports we're using. It's going to do the same for Connection Manager to figure out what the Connection Manager is listening on. It'll also let the Connection Manager use it to figure out what are the servers the connection manager knows about. The next one is the INFORMIXSERVER/bin/on-cmsm. There's the binary file. This is the command we're going to be using to start and stop. Connection Manager comes with a couple of configuration sample files, standard INFORMIXSERVER/etc. So the sample's there if you want to browse through it. Just like anything else, save the sample file there so you have your default sample, create a new file, and put it wherever you want it to be. There's also a setting where I'm just mentioning as a CM alarm program environment variable. On a failover situation or on a error in Connection Manager, it will call the CM alarm program value. You can create a shell script that'll do something, whatever you need it to at that point, sort of like alarm program does for Informix. So there's a few ONCONFIG parameters that matter for this. The first one is DR auto. If using HDR, you're probably familiar with this already. This is how in an HDR environment you handle failover. By default, it's always been 0, 1, and 2. So 0 is there's no automatic failover. 1 and 2 are on the different levels. When they introduced Connection Manager, they added 3. If you have 3 set, it'll actually trust the Connection Manager to tell it when to failover. The next part is the HFOC order. This is what is the failover order going to be between HDR, RSS, and SDS. So you can actually tune it if you wanted it to fail over to an RSS or an HDR. You can set it up to change the order. It all depends on your environment if you're going to touch that. So how do we actually run this? The simplest way is just with the on-cmsm binary, and we give it the -c environment, -c variable argument, and then pass it the configuration file. Again, the configuration file can be anywhere on your system. I often put it in the INFORMIXSERVER/etc just because it's easier to know it's there, but wherever makes you happy. You can also set the cmconfig environment variable. This one can be really useful where if cmconfig is set, it'll actually use that environment variable in place of needing to pass a -c parameter. So you can just run on cmsm and it will start it up. If you use -k, it'll shut it down, and -r will actually reload the configuration file without restarting the server. So if you're making some changes, you can just do a reload and you don't have to worry about it impacting users. So it's a pretty simple program. That is the only parameters it has, -c, -k, and -r. So basic example. So we have our instance running. This is our standard configuration here, very, very simple. Our instance TCP, we tell it on-sock TCP, our host name, host IP, whatever it might be, and we're giving it the SQL exec, for the port mapping. So very, very simple. That is what our instance is running on. For Connection Manager, we add a new entry. So we're going to create a Connection Manager listener. So it's going to look just like the SQL, or just like our Informix one, where we're giving it the listener name, it's on SOC TCP or on TLI TCP or whichever kind you're connecting as, your host name, and then your port. The port has to be different than your Informix listeners because it's going to be listening on a new port. So just like if you have multiple Informix listeners, you need to have different ports for each of those. You need to do the same for your Connection Manager listeners for a particular IP address. I do highly recommend that, and we'll go through some more examples of SQL hosts, but that you well document your SQL hosts and choose your names wisely so it is easy to manage down the road when you're dealing with multiple systems and multiple environments. So you always know which ones are your Connection Manager ports and which ones are your Informix ports. So your cmsm config, again, this can be named anything you want it to be, but I just wanted to create a really, really simple one here just for a very simple demo. So first thing is we give it a name and then a log file. So this is the Connection Manager name for that particular Connection Manager, and then the log file it's using. Then we're giving it a cluster, which is for HDR replication, and give it a name. We tell it the Informix server, this is the primary one it's looking for, and then we give it the SLA, and the SLA is our listener. and then we tell it the DB servers we want primary, so we only want connections coming in to go to that primary server. So in this situation, as a client, I will go to something called report group. That's my new Informix server value, whatever we defined in SQLHOSTS. When I connect, I will connect to Connection Manager. Connection Manager will tell me this is the primary server I'm going to. It doesn't matter which of the 3 servers, the HDR, our primary HDR, RSS, doesn't matter which one is currently the primary. This is going to redirect me that way. So again, very, very simple, but this is all you need to actually have it running. So then we actually have the configuration. So again, just to break it down a little bit, again, we give it a name, log file, we're telling it logs on, and we give it a timeout. So I'm going to jump right into the little bit deeper section here, and I'm going to go through the parameters. I'm going to go through all of them. This is sort of my replacement guide for what's out there in documentation right now. And I want to do this before I go into examples and the demo because I want to kind of go through all of the options to detail how each of them works. So then when we actually get into the examples, it'll make a little more sense. So the first part is the Connection Manager parameters. So these are all generally at the top of your Connection Manager configuration. They are per Connection Manager instance. So if you're running a cluster of Connection Managers, this may be unique per server. So again, the name, it must be unique across the cluster, and this is the cluster of Connection Managers. So you may, most times I find people either name Connection Manager 1, 2, 3, 4, 5, or Connection Manager and then host name, something so you know it'll be unique and it's easy to tell which server is which. Our log level 1 is on, our log file, the path to Connection Manager log. Note that this will log every single connection that comes in by default. So some environments that may not want to log IP addresses, you may want to turn it off or figure out a secure way to do that. So the next one is the CM timeout. And there's a few timeouts we're going to talk about here, which is why I really wanted to detail this. This one is the Connection Manager timeouts. If you're running multiple Connection Managers, what it actually will do is, and I just realized I made an edit on this, and it's TIMEOUT. I will be putting this slide deck out afterwards. I'll get it fixed. But it is the number of seconds to wait for a response before you go to the next highest ranked Connection Manager. So if a Connection Manager is timing out, server's gone down, network port's gone down, whatever it may be, this is how long it'll wait until it treats the next highest Connection Manager as the authority. This is the primary Connection Manager. The only time this actually matters is if you're doing DR Auto 3, and we'll show some examples of that. The next one is the event timeout. Again, this only matters if DR Auto is 3, but it is the number of seconds that it waits before it will actually issue a failover. So if a primary goes offline, it will go in and count this many seconds, and if it doesn't come back up by then, it'll issue a failover. If a secondary triggers primary offline, it'll actually trigger the failover beforehand because then it knows for a fact that there is supposed to be a failover. Secondary event timeout, same sort of thing. It's how long do you have a timeout with a secondary server before it disconnects saying it's offline. It'll try reconnecting later on, but it'll stop trying to connect if it exceeds that threshold. The next one, this is kind of cool, is the SQLHOSTS. You can either set it to default, which does local, or you can do local, remote, or default, which is both. What this will actually do is tells it when I am probing for servers, which SQL host do I use? Do I use my own SQL host, the one of the local system, or do I connect to my primary server and use their SQL hosts? By default, it'll use both. So it'll read every server in each of those. So you don't have to hard code every server onto the local connection manager, which can make it easier to manage if you have a very complex environment. Local IP is really only used if you are binding Connection Manager only to a specific IP address. Generally, I really have found very little use because the SQL host listeners will handle most of it, but you can force it if you needed to. And macros can come in handy. It's basically a macro is you can use effectively a templated variable for your Connection Manager script. So it can mean that you can have the top section of your Connection Manager be a bunch of macros, and then the rest of the definitions be actually using these templated fields. So that way it's easier to manage it when you're deploying it to many Connection Managers. All you have to do is go look at the little top section and be able to just change those variables. So that is the top part. So that is the top of your Connection Manager configuration. Then there's the bottom part, which is our actual connections. So there are 4 connection types we're going to focus, or 4 connection types total, but we're going to be looking at all of them, cluster in particular. So the biggest one is cluster. This is for your HDR environment. So this is expecting primary, secondary, maybe RSS, maybe SDS. There's grid if you're running an ER grid, or REPL set if you're just running standard enterprise replication. There's also server set. This is if you're just connecting on a one-to-one environment where you just have, this is my Connection Manager, this is my standalone server. You can use server set to pass to that. The formatting is the same between all of them. It's just slightly different parameters depending on which one. So the first part you have is the connection type. So you have, in this case, it's cluster, so it's HDR. Again, so if it's grid, you'd have grid. If it's standalone, it would be the server set. You have, and then you give it a name. That name needs to be consistent across your group of connection managers if you want them to support the same listeners the same way. So you'd have cluster 1 on every one of your connection managers, so it knows exactly which one we're talking about. And then you have brackets, and then inside you have your environment or your variables for defining that connection. The first thing you say is your Informix server. So this is the primary Informix server we're going to connect to. So this is what we're going to be looking at. This needs to be in the local SQL host file for the connection manager, but then it can pull the rest of the data through the remote SQL host if needed. Then the next thing you do on the next line is SLA. This is our listener. So in this case, we're calling this listener report_1. This can be named however you want, followed by a number of parameters. We're going to go through all the parameters in a moment, but just for sample here, in this case, we're going to do DB servers. This is which servers we're connecting to, and this one is primary and our HDR, which is our secondary. Then and then we have, these are all in the same line, or you can use the slash if you want to break lines. Then the next one is our policy. There's a bunch of policy values. Workload is which is the least busy server. So this would be an example of a reporting system where we want it to go out, somebody issues a report request, it may be a heavy query. We want it to go out to the least busy server to go and return the data, and good to go. And because it's reporting, should be a read-only, so it doesn't care if it's on the primary or your secondary. The next line is our FOC, so this is failover order. And in this case, we can actually tell it that we want the order enabled, so we want it to handle failover if it happens. So we're assuming DR auto is 3, and we're setting priority as 1, so we're saying this is the first. This is the highest priority server of the cluster. So if this one were to go down, then the one marked priority 2 would take ownership next. And again, the only time that matters is which connection manager is going to issue a failover command. And then we're including a last line, which is CM alarm program. So we're saying if something happens, there's a problem with this particular listener, this is the connection manager alarm program we're going to call. So I just there's a few slides here that probably be more useful going back into it later on. I just kind of spell out every variable on here so you're familiar with what it is. I'm not going to reread all of it. Again, we will be putting these slides out after the fact, and you can actually find pretty much all of this with just a a couple more typos at that point from the IAG 2017 conference set. I did do this presentation there as well, or at least an earlier version of the presentation. So next thing is Informix Server. So this is what I'm going to go through all the parameters now for this type. The first one is Informix Server. So this will be the same for all 4 types of connection, you know, grid, ER, standalone, or cluster. This is the server or servers it'll initially connect to. You can set a group to this if you want it to reach out to multiple. So this is the first thing that comes up. It needs to be able to connect to these servers, or at least one of them in the group, to be able to query and start up that listener. If it can't connect, you will get an error on the Connection Manager instance. Next one is SLA, Service Level Agreement. So this is the listener. This is the directive of how the Connection Manager is going to handle a group of servers or a single server. Again, needs to have similar settings for all of this if you have linked connection managers. And every SLA that you have, and you can have more than one per group, will have its own listener port. So make sure listener port and IP address. If you're running multi-home system, you could use the same port for different listeners as long as they're bound to different IP addresses. But I don't recommend that because that tends to be more of a headache than just defining a new port to use. Next one is DB servers. So this is the list of servers you want to actually connect to and manage, and the order you want them in. So you can use server name, you can use a group name, the alias, or the HDR type, so HDR, SDS, primaries, or any, which will just pick all of them. So spelled them out here. So primary, HDR, SDS, RSS, or any, which just if you're feeling really lazy and you just want to do whatever one is most available. The next one is the mode, and this is an important thing to note, so I really want to highlight this. By default, if you're running the old version of Connection Manager, the one that shipped with 11.5, everything is proxy. Come 11.7, they introduced the SLA mode option. By default, they've changed it to redirect. What redirect does, and I have some graphs or demos on this, is it'll take the connection coming in and actually pass it off to the Informix server. So the client itself will have the connection settings of the Connection Manager, but after the Connection Manager determines the correct server to connect to, it'll hand off the connection and then step out of the way and let the Informix client and the server connect directly. It's faster because you then get the Connection Manager out of the way, but it does have some limitations. The first one is this was not supported until the CSDK3 and the JDBC 3.5.1 versions. So if you're running an older version of the CSDK, this isn't going to work. It won't. You'll get an error. Also, if you're not using one of those 2 connection types, you're using an ADO DB connection, you're using some funky third-party driver, you're doing some other kind of connection outside of the standard, this will not work. You will get an error, or it'll just say it can't connect. The other option besides redirect is proxy. What this does is it actually passes all the data through the Connection Manager. So the Connection Manager takes the request, submits that request to the Informix server. The Informix server generates the data, sends it back to the Connection Manager. The Connection Manager sends it back to the client. This is nice because the client doesn't know it's talking to Connection Manager. There's no special logic. Anything that can connect to the Informix server can connect to a proxy connection. The downside is it means you have an extra hop for the data, and it means there is higher load on the Connection Manager server because it's having to handle and pass all that data. The one other place where this does come in handy, though, is if you want to use Connection Manager as a middleman, such as through a DMZ, you do want to use proxy because you don't want the clients directly talking to Informix. So, as an example, this is the redirect. So a client connects to the Connection Manager. Connection Manager follows the rules, tells it this connection should go to group 1. And group 1 knows that the secondary is the correct choice in this case. You know, Connection Manager tells it go to secondary or go to least busy or what have you. And what will happen then is the secondary will reach out to the client and talk directly. So the clients are connecting to secondary, the Connection Manager is now stepped out of the way. The only thing that'll happen here that the Connection Manager will get involved with is if the secondary server at this point goes down, the client should issue a reconnect statement, just like with any other environment. You know, if it can't talk to the server, it should try to reconnect because maybe something happened to the connection. When it does, the whole process will start again. Connection Manager will go through its list of rules, tell it what server to connect to, and the systems will then connect to the correct server, let's say primary or RSS or whatever server is now available. With a proxy connection, the clients will connect to the Connection Manager. Connection Manager will tell it where the connection's going. Then that'll point to, let's say, the primary server in this case. Then what will happen is the primary server will issue the connection with the Connection Manager, and the Connection Manager will then take the requests and the data and transfer it back to the client. So we have an extra step in the middle, may introduce a little bit of latency. It all depends on your environment, which one is correct. Quite a few clients I have run both proxy and redirect. They'll have their legacy applications through redirect and then through proxy, and then their newer applications, everything they verified, run through redirect for the performance enhancement. The next one, and this is an under-documented feature in my opinion, is use aliases. This is another flag on the SLA connection. By default, it's on. I have found many cases where I really want to turn it off. The reason being is what will happen is by default, when you go out, you connect out to the remote servers, it'll query their SQL hosts and pull every connection they know about. Problem is, this will pull every connection they know about. So if you have DB server aliases set and maybe you have an HDR specific port that you want only HDR or ER traffic to run on, or you've got listeners of other types, if use aliases is set to on, it'll pull those into the list. So it'll try actually sending connections over to those ports thinking they are valid. If you turn it off, it'll only use the DB server name to connect to. So you should be fairly safe there as long as you set your primary TCP port to your DB server name. That's the one gotcha there. But this can be an important thing. I've seen many clients that have multiple DB server aliases set to all sorts of different specific needs, and you don't want those trying to be pulled in when clients are connecting. Next one is workers. This only matters if you're running proxy. By default, it is set to 4, but it is how many threads, worker threads, the Connection Manager is allocated. Technically, it doesn't, or this will impact redirect as well, but unless you have an insanely busy server, the default should be fine. But if you're running on proxy, this will actually impact your performance, because the more number of threads you have running, the more processing power Connection Manager has to handle more connections and more data throughput. So if you're dealing with a fairly heavy proxy server, you really want to look at tuning workers up. I've not found a good guide yet, and I've not been able to get a proper benchmark on exactly what is the sweet spot for number of workers. Usually between 8 and 16 seems to work pretty well, but it all depends on your environment. So if you're seeing connection problem, or you're seeing speed problems and you're dealing with proxy, you may want to try tweaking this up or down a little bit. The next bit is the policy. So this is, we're actually setting the rule for what the Connection Manager is doing. If you're dealing with more than one server, so you're dealing with any, or you're dealing with HDR and primary HDR, or whatever it is, or you're telling ER, you're telling the grid, we're going out to any of the grid servers, whatever it is, policy comes into play because we want to know which server do we send the client to. The default is workloads. what it will actually do is pull the servers periodically to see how busy they are, see how many resources they're currently using, and it will try to send the client to the least busy of the current servers defined. This can work really well with a grid situation or an ER situation, because you may have 6 identical servers and we want to go to the one that has the least amount of work going on it right now. On the same token, there's round robin, which will just send each connection in a row to the next available server. Can work really well if you have a very consistent load, but if you're spiking a lot, you may keep putting all the busy people on system 3, leaving the others underutilized, but it all depends on your environment. For failure, this only works for ER and grid, but it's the fewest apply failures. So it's usually the one with the best connection or the most reliable replicate set. So it'll try to send it there. Same token with same type with latency, which will actually go out and go to the fastest responding server. So it usually will be the quickest to come back. Again, depends on your environment. There's another one which is, and this came in 12.1 XE2 and 11.7 XE8, is sec apply backlog, where if this is for an HDR system, and generally this is for RSS, but you can set a backlog threshold where if a server gets behind so many pages, it'll stop sending requests to there. So you could have 5 or 6 RSS servers, and you set this, and once it exceeds that threshold, then it will basically kick a server out of the available ones for a while until it comes back into scope. So if you have a flaky connection on one of them, it's not going to send clients there if it's too far behind. So the next section, so that was all the SLA line. So your SLA line is really, really important. The next one is FOC, which is the actual failover occurring rules. It's also setting the section to set the priorities of servers. This really only impacts it if you're having automatic failover. First function or argument for that is order. So this is you basically superseding the HAFOC order from your ONCONFIG. Same parameters. Basically, it's the which servers do we fail over? What is the priority level between SDS, HDR, and RSS? If it's enabled, it'll use the order defined. If disabled, it just won't actually, it'll use the HAFOC order. So priority is the priority between your connection managers. Lower is the higher priority. So 1 is your highest priority, 2 would be the next highest, etc. So if 1 goes offline, 2 would then be your arbiter, in case of a failover situation. So if your primary goes down, your connection manager 1 goes down. Connection manager 2, once that connection manager timeout's been exceeded, will take ownership and say, okay, I am now the arbiter in case of problems. Primary is down, we're going to issue a failover. Timeout, to be aware, this is the additional time for the timeout, basically for a failover to occur between servers. It'll look at the value of event timeout and add this to it. This is in place, so if you want a particular cluster or a particular server to have a higher timeout than the default, because it may have a flakier network or you want to give some more flexibility there, it's available. It defaults to 0. It all depends on your network whether you want to set this or you need to set a higher value. Most cases, you'll just leave it at 0 and use the master event timeout to define, but every place may be a little different. The next one is your SQL host value. Default, it reads your local SQL host for your values. It'll also then check the remote SQL host for additional hosts. You can actually set up the Informix server value if you need to, for what the one it's going to query off of. So again, the SQL host value, it's just telling it where are we connecting to and to read. Also note that in your SQL host file, again, you need your SLA listeners defined in your SQL host. We'll do some examples in a moment. Also, I highly recommend when you're looking at SQL host file that you're actually setting up groups for everything, your clusters, your HDR setups, as well as your actual connection managers. You know, if you have 4 connection manager servers, make all the listeners a single group. It'll make your management easier, and it'll make your application development easier, or your application setup easier, because you can point to the connection manager group, and you've got an extra layer of redundancy there. So a little more advanced sample configuration. So again, we're giving it the name, connection manager 1, log 1, so log's turned on. Got a log file we're going to, and we're setting the event timeout to 20. Then we're setting up a cluster, so it's an HDR cluster. Our Informix server is going to connect to cluster 1 as our primary that we're going to connect to. Our SLA is going to be report _1. We're going to primary, secondary, going to workload. So why I actually spelled this out here is there are 4 different names in your connection manager config, just for a very, very simple setup. And I wanted a single slide, and why I'm highlighting this is because if you have not set up connection manager before, when you go back to do it, pull up the slide and it actually highlight what name goes where. So again, the first name is the name of the connection manager. Second one is the cluster name. The only place this matters between the different connection managers. It can be anything you want it to be. The third one is the actual TCP connection, TCP name, or on-sock TCP name of the Informix server we're going to connect to as the primary. This can be a group, this can be a single server, whichever. The last one is the SLA name. This can be whatever you want it to be. However, this has to be in the local SQL host, because this is the listener that the connection manager will listen on. Just like DB server alias needs to be in SQL host, so does the SLA value. So again, the SQL host example, we have cluster 1 here. 2 Informix servers, 1 on server 1, 1 on server 2, and then we have a group of connection managers. So we have the report group. So on the second section there, and that one we have report _1, which is going to be on first server, and report _2, which is going to be on the second server. But for the application standpoint, if I just connect to report group or to the report group, it'll just go to whichever server is available and reaches first and fail over if it needs to. So in my case here, it may go to several servers behind Informix servers behind the connection managers, but now I've got full failover even on the initial connection. So I have multiple levels of redundancy here. So I could lose a fair bit of my environment and still have no difference as far as the users are concerned. So the actual application setup. So let's say we have multiple report groups, or the application setup we just went over. We tell it to connect to the report group. It'll go in and automatically connect to whichever connection manager we tell it first, which is report group 1 or report 1 normally. Can't connect to that, or connect to the second one. And we should be all set. Or we can have the connection connect directly to report 1, and that'll work fine too, as long as that server does not go offline. So I'm going to get into a demo here in a moment, but just to show you what the actual connection manager log looks like, this is what actually startup looks like, where you actually have 4 listeners starting in this case. It actually tells you what the rules are applied to each one. So the first one's just an HDR secondary and RSS available. So it's a round robin read-only for worker threads. The second one, goes uses secure apply backlog to 5500 and workload. You can set up multiple if you need to. And goes through, gets all of them up. You can see some are proxy, some are not, some are redirect. And then you actually see it starting at 22:45, 42 seconds. it successfully connected to May TCP. This is one of the Informix servers. This is the first one it listens to. And actually we'll go through and figure out which are the primary and which ones are the secondary servers. This is just continuing. It then connects to the next system, goes through, sees which ones are primary, makes sure it can connect. It'll show you failures here if it can't connect to any of the servers, or if there's something where something is not configured correctly, you'll get error messages that are fairly useful. Usually the error the log in this will give you a pretty good idea of what the problem is. And it'll actually just show you the listeners coming up, the connections being identified, and this is as it's going through reading the remote SQL host files to figure out where everything is located. So, and then when connections actually start coming in, so this is from the application, I'm coming in, I'm looking for the listener report RR. It's going to do a redirect. It'll say proxy if type. It's a squealy connection, so if it's DRDA, it would show you that. Where it's coming from, the IP address, and then where it's actually going. So it's coming into May TCP, and then it's actually getting redirected to May at port 10,088. And then again, I'm coming into a different report, and it's going to go over to Fury, and it goes over to a different port on the Fury system. And the reason in this case, it's actually doing a NoSQL connection. Lots of different ways you can have the rules work, but this is just showing some different connections and what they look like. There's also an onstat cmsm variable brought in. This will show you all of the connection managers listening, and this can be run on any server that they're connected to, and what the rules are. So if you ever need to go in and query for what your current configuration is, this will show you. It will show you how many connections total are in, the port number, the protocol, all the useful information you may have. So best practices. The big one is use groups. Don't just like, if you've ever done ER, that's one of the first things that you're told to do is set up everything as a group. Do the same for Connection Manager, just because if you add more servers in the future, you expand it, all you have to do is just edit the group to add a new server. You don't have to modify all your connection strings. It's a free service. I do recommend you run more than one Connection Manager. Because if you're going to a system that'll give you more failover capacity, have more failover capacity on that system. If you're running a single connection manager, doesn't matter if you have 5 different Informix servers that everything is nicely replicated across. If that connection manager server goes down, you're disconnected regardless. Try to get the third point here, and this is not a hard and fast rule, but it's one I do recommend, is try to separate the connection managers from the instances themselves. It makes it easier to deal with downtime if your Informix server goes down for maintenance, that your connection manager server is still up and is redirecting. Again, you may have cases where you want them paired together. That's fine. There's nothing really wrong with that. But it's easy enough, and so many people are running in environments that spinning up a small system is easy to do in production, that having small connection manager servers available is not a bad thing to do. Again, proxy mode, you're going to pass all the data through the connection manager. Keep that in mind for your network, that you may be passing through huge quantities of SQL data now, or data coming in to or from the database now through your connection manager. So your network needs to be able to handle that without adding much latency. Try to get the group of connection managers rather than a single for your application. And one thing we found with a couple of clients is make sure your applications reconnect with a bit of a delay. The reason for this is we found a number of clients had applications that their process was, if the connection is disconnected, reconnect. And then so what you'd have is, if primary server went down, there's a 60-second window before the connection manager kicked off the failover. But the application would go reconnect failure, reconnect failure, reconnect failure, fail in the span of about a second. So what you'd have is the failover would happen fine, but the application would have tried all the reconnects immediately, all of which are going to fail because the connection manager has not failed it over yet. And then you basically have a, the application coming back going, database is not available. I recommend 10, 20-second window or give multiple retries on it, because if your primary server goes down, you don't want a failover to happen immediately, because some may have actually unplugged the network cable for 2 seconds and plugs it right back in when he realizes they unplugged the wrong one. Or you could have, some little glitch, disable the network for a moment, or the server could just be, something could have happened on a switch that it's slow to respond. You don't want an immediate failover. You want to give it a few moments to see if things kind of right themselves. So having the application be able to kind of take that breather is not a bad thing to do. This is also where if you need that 24/7, 365, by 1 second downtime is too much, and reconnects are an issue. If you're doing a round robin or a latency connection, as the actual type for the SLA, what you'll actually have happen is when it issues that reconnect, the connection manager will go, okay, we'll go to the next server. But if you're doing it with it's a workload, or you're doing it on a priority, so it's, you always do your primary is not available to secondary, it may take a moment before it will kick off down the road. Just things to consider when you're setting up your environment. So I'm going to actually get back to the warning messages after I do a little demo here. And as any time with live demo, things can go wrong. We'll find out here in a moment. Already had one of my systems fail earlier. So what I've got here, and I know the eye bleeding colors, but I really wanted to make them different, is 4 servers. They're actually a little Raspberry Pi system sitting behind me, all networked together. It's a very, very light system. But what I have is 3 servers in an HDR environment. So I have Fury as my primary, Colson is my updatable secondary, and May as my updatable RSS. I just had them updatable everywhere just because I was doing some testing on it. You don't need that by any way. Any normal HDR environment will work fine. The last system I have down here in the bottom right is Fitz. Fitz is just running the connection manager. So it has the, it's just got Oncmsm running. I have, let me actually show you the startup script. I set the cmconfig value over to your cmsm.cfg, and then all I do is start it with oncmsm. No parameters needed. It's up and running. So to show you what the connection looks like, so we're going to onset G cmsm, and this is actually showing you the SLAs we're running right now. So I apologize. Let me expand just a little bit here. So we've got 5 SLAs running right now. It's all off one connection manager. So we've got our primary CM. This will only go to our primary server. So it doesn't matter which one's primary, it'll only take you there. So if I'm doing a standard HDR and these are for my OLTP system, I want it to write, it's always going to go primary. Second one is a report system. This is our report workload. This maybe is our accounting division. We want them to be able to get the reports back as fast as possible. This will go to either our HDR secondary or our RSS system, whichever is least busy, and run there. Next is report RR. This will do round robin. So if we're doing a whole bunch of reports kicked off in sequence, I may want to do that so it spreads them out. So it's same servers, just round robin. Then we have our current RSS, which will only go to our RSS server, and only ones that are relatively, well, 5,500 is a pretty big backlog, but you know, there I just used as an example for what it looks like. And then you notice I do the plus workload. So it actually will do the workload of our RSS servers, and then we'll actually then kick off any that get behind the backlog. And lastly is our proxy HDR, which is a proxy connection rather than a redirect connection. You can see the failover arbitration. This is the CM1 is our unified connection manager. This is our current primary. What server it's running on, host name is fits, and order is, this is our default failover order is SDS, HDR, RSS. All, you know, every time may be different. In this case, I am only running a single connection manager. There's nothing from stopping me from running as many as I want. So what I'm going to do here is I'm actually going to kick off a little script on fits. And I chose bad colors because I know the green does not show up real well. So I'm going to run sysupdate. Sysupdate is a little script that pulls the CPU temperature from Linux and goes and inserts it. And what I'm actually doing is I'm going to connect to our primary CM. So this will connect to whatever server is primary and actually issue the value, check against it to see where I'm connected. Thanks to Mike Walker for the SQL on that. And then actually insert the temperature, the current CPU temperature, to the temp storage direct table. So this will connect in to whatever is the primary server and issue a simple insert and display what server it's connecting. So I'm going to get that running here. And what I have set up on all of these is DR Auto, and by the way, DR Auto has to be set the same for every system in your HDR environment. Otherwise, you will get all kinds of errors because it will, you know, it has to be the same because you can't have one system try to fail over from a remote site, one from a local site, and one say no failovers at all. It gets really confused. So we got the script running. It'll run about every 5 seconds. So what I'm going to do is actually unplug Fury. So I'm physically removing the, actually powering off the whole thing. And what we will see here in a minute is the connection manager will actually kick off a failover. So assuming everything goes well. What I'm actually going to do is duplicate the session. Yes, I know I'm running as root. I should never do this. So I do not have DNS set up on these, so there's a little bit of a lag connecting in initially. And so what we'll actually have, this will take a moment. So right now, Fury is non-responsive. Colson is currently listed as our updatable secondary. And now we have down here in the bottom left, you can actually see the server is disconnected. So Fury is down, and the arbiter is kicking off automatic failover. Yeah. So we can see down here the connection system. We got 2 in Fury, and now it's not able to connect to anything because it's coming up. We're in the middle of the failover, and it has not failed over yet. So actually, do is just tail F the online log here. And so what's actually going to happen is we've got the 60 seconds before the event timeout happens. So that has been hit. Now it's doing another 60 seconds as it's actually going through and disconnecting all of the different potential lost connections. I did not have DB server. Yeah, there we go. So it needs to do all of the timeouts, and I had more than one server listening on Fury, so it had to time out all of those before it's going to issue. So what we are seeing now is I'm actually going to move the fits to the upper left where Fury was living before. And we can see updates are blocked. And what we should see in a moment is, if this works correctly, again, fun with live demos, that we should see Colson promoted from HDR secondary to primary. Yeah. So it's going through all of them, making sure all the disconnects. So you're getting the errors, the 90H trap because it can't connect. Okay. So we've hit the timeout, and now it's actually bringing up Colson. Again, nothing up my hands. I'm not physically touching the systems after I pulled the power cable on Fury. And what we've done over here is we can actually see that the server type of cluster, Colson is now primary. We've seen that May is still RSS. This does not promote them automatically from RSS up to primary. And we see down here in our application, we now have connected system Colson. Because it's looking for the primary server, it's automatically, completely hands-off, switched us both on the application and on the database side from Fury over to Colson. For any of you wondering that haven't heard my explanation, when I originally set up this demo, I was watching a lot of Agents of S.H.I.E.L.D., so hence the naming. So now we have our primary server of Colson. Fury is offline. It is unplugged right now. May is our secondary. And we have the failover having succeeded, and we can actually see the connections up here where it's now pointing everything over to Colson. So now what happens if I disconnect Colson? And I'm sure I disconnect the correct one here. And we're going to issue another failover. So Colson is now disconnected. I just literally pulled the plug on it. And what we should see is the application is going to have some more failures. Again, real world situation. Your server's caught fire, the switch is blown up, your data center's just gone dark. Something's happened with your primary. So we don't necessarily want it to automatically be immediate. What we want is to give it a few minutes, see if it cleans itself up, and then if it doesn't, then fail it over and get people going again. If you have things that are scheduled, so you actually bring a server down manually, what you'll see is it'll automatically do the failover. It'll see that the secondary is telling it the primary is coming down cleanly. It'll tell it, okay, we need to do a failover now. This is something to keep in mind, because if you don't want to issue that failover, you want to make sure that you actually turn off the connection managers or before you issue that failover. Otherwise, it will, or issue the shutdown of the primary. Otherwise, it will try to issue that failover. All depends on your environment, how you want to do it. But if you're working in that environment, let's say you're doing OS upgrades, you bring the primary down, the secondary immediately starts the upgrade process, turns itself into the primary. That's probably what you want to have happen, because then you're running entirely on your secondary server. Your users don't really notice a difference other than a few second outage while it updates itself to primary. And then you can do all your work on what was your old primary in peace. And then when you're ready, you can switch them back. So you can see that we actually have issued failover starting here. So it's starting the automatic failover. What we have done on May is May was the RSS. May is now going to fast recovery mode. So it's actually automatically promoting from RSS to secondary and then from secondary up to primary. And we now have primary mode. So it's now done the automatic update, full failover, and now we're starting to see connections. The next one that comes through here should actually be pointing it over to May. So again, we have automatic failover. We're having our connection manager redirect us to the correct system. There's lots of different ways that we can go about playing with this, but this is a simple example of where this really comes into play. Again, the only thing I have done here during this demo, other than move some windows around, was unplug two systems. I have issued no commands. There's nothing up my sleeves. This is what the system does really well. Not just the failover, but actually managing the connections and managing the rules. So I'm going to get back into the slide deck here. Kind of go through a couple of things that I like to bring up as potential problems. The first one, and I'm going to go in detail, split brain, listeners missing information, alias issues, trusted status, and DB server name. So split brain. This is one of the, I'm going to come back to the slide actually, this is what a split brain is. So if your primary server loses network connection, your primary server is still online, but somebody cut the cable, the switch failed, whatever. So it is now disconnected from your network. Connection manager hits that timeout window, promotes a secondary, assuming the primary is down because it can't reach the primary. But the primary is still up, it's just running disconnected from everything else. When the network connection comes back up, you now have two primary servers because your secondary is now primary, your old primary is still primary. The problem here is that and this is specifically with HDR, this is not an ER problem, but with HDR, because everything is based on the log chain, you now have two different log chains. As soon as, even if nothing was coming through, Informix does things under the covers, so logs still move. So you now have two different log paths between your primary and your secondary, and you have no way to reconcile it. All you can do at this point is take one of the systems offline, restore it from backup, and start replication again. That's about it. This is one of the biggest problems with automatic failover. So to make sure to handle this, having your connection managers be off the physical servers can be helpful, because what it will do will actually give a better trace on the network connection beforehand. You can actually put in, steam alarm programs and things to check if you need to. But the reality is, if you can't trust your network, I would not recommend doing automatic failover, because it's really easy to get into a split brain situation, which can be really problematic, especially if users directly connect to a server. So when the old primary reconnects to the network, suddenly people are doing work against it again, then you have to figure out how to reconcile. This is one of the biggest dangers and something to very much keep in mind. So, biggest thing is have reliable network connection. If you can't trust your network, then don't do automatic failover. Do a manual one. You can script it. There's lots of things you can do to help make it easy for your NOC folks to do a failover, but make sure that they are, a human is doing it, not a machine. Or have really clever scripts and not have to have a human, but that's on your environment. So you can also use the Connection Manager alarm program to actually shut down the primary. So IBM actually put out a DeveloperWorks article on this, so it actually walks through how to set up the scripts to handle that. So it is one thing to consider. So the next one is, if your listener is missing information, you'll actually get a 930 error trying to bring it up. So this is, you don't have the correct listener name, it's not in SQLHOSTS, it doesn't have a valid port, etc. Or alternately, if your port's in use, you accidentally define the same port as one of your Informix ports. When the connection manager comes up, it'll try to bind to that port, it'll fail. You'll get a 930 error. It will be listed in your connection manager log file. If you're not reading that log file, you suddenly may have users not able to connect. But hopefully all this you would have worked out during testing anyway. Big thing I talked about a bit with the aliases is if you have aliases set to shared memory or to like a path, a network connection that's like a direct crossover cable for HDR replication or ER replication, it'll try to use that. If it's a valid connection, Connection Manager will try to get people on that connection because it tries to spread the load. So if you have those sort of situations, turn use aliases to off, and it'll make your life much easier just to go off the primary TCP connection. Trusted sources, if your servers do not trust the connection manager, so your connection manager can't connect without a password, it's not going to be able to connect. You'll get an error in the log. There's sorted password management processes. There's a bunch of really good tools that they put in for enterprise replication using the encrypted password tools. You can set up that way. There's rhost, host-equiv, or the new remote server CFG variable that was added to version 12 that lets you use a separate file of potential trusted hosts. Again, you can use the on-password if you need to encrypt the file. There's a lot of guides to setting this up. So you can use this to trust systems without actually having to do the old rhost type trusting. So some more resources. The Connection Manager manual, it's there. Honestly, rather than typing in this URL, I just Google it, Connection Manager example. It's reasonable, but they don't really explain all the settings real well. It does take a while to dig through it. This is what actually spawned this talk. IBM has a DeveloperWorks article on the different replication technologies. If you're not using replication in Informix, you really should look at it. If you have enterprise or workgroup, you basically have a licensed copy of Informix, you're allowed, check your license on this, but you should be allowed to have a warm standby failover server available to you at no cost. I highly recommend doing that if you're not already. It's not entirely Connection Manager focused. It actually doesn't mention Connection Manager, but Andrew Ford has a great article in his blog I like to mention where he does the best step-by-step guide to setting up HDR that I have seen. I do highly recommend taking a look if you're looking at getting into HDR and you have not done so already. There's also a list of Connection Manager alerts. So these are all the potential alerts that may come up. Or may get thrown from Connection Manager for the CM alarm program. So if you want to figure out what you need to trap, that's a good article to go into it. So wow, that did weird things. There was a little question guy here. I'm going to take questions here, and I've got a little bit afterwards. But let's see what we've got in chat. Does anyone have any questions right now? I'll give folks a couple more minutes. Feel free to drop me or Lester a question if you have it. Couple of upcoming things. Our next webcast is Informix Best Practices. It's a really, really good talk on Informix auditing by Mike Walker. Auditing is something that is often underused in the Informix world, and he's done a really good job of spelling out how to get started with it. We've got some other stuff we're working on. We will be announcing our end of summer into fall webcast set fairly soon, so stay tuned for that on our website. As always, we have replays of all of our webcasts prior on the website for free. Please take a look, and do feel free to reach out to us with questions, comments. If you have things that you felt were incorrect, whatever, let us know. We'd love to hear feedback. We have an upcoming WAG meeting, the Washington Area Informix User Group, August 8th, Tysons Corner, Virginia. It's 8:30 to 1. We actually have two really good talks already. One is what HCL is bringing to the Informix world. Stuart's coming down. He's president of the IIUG. It should be a really good talk about the future of Informix, what the partnership with HCL means for all of us as users and as the end user of Informix. And then we have Sean Moe coming down to talk about enterprise replication. So he's one of the lead guys there. It'll be a really useful talk if you're either using ER or looking at it. The user group meetings are free. We provide food. Just please go to the website, wag.org, and RSVP, because we do have to get you on the list to get you into the IBM building to make it. There's also more information on the website and information to sign up for our mailing list. So we have training coming up this year, September 11th through the 14th. We're doing our advanced Informix performance training, our tuning class. September 18th through 21st is our introduction. It's Informix for database administrators. Our policy is all of our classes you can take online or in person. We have a mixed set. We have in Annandale, Virginia here, we have plenty of seats, as well as we do it through WebEx. Seems to work really well both ways. We also guarantee if we get at least one student, we will not cancel a course. So we have stood by that promise and have not broken it in the past, and we're not going to in the future. That's something really important to us, that if you sign up for one of our classes, that class is happening. Information on just some of our support offerings. So we do remote DBA support, performance tuning. We will do training, both the classes here, and we can also be scheduled to do on-site courses. We do Informix consulting of all types, as well as database consulting, and we do development work. And if there's anything else that you're interested in, please feel free to reach out to us. Thank you. See if anyone else has any questions have come in. Nope. Okay, so we'll be posting the replay of this on the YouTube and on the website, as well as the slides. I will also include the Connection Manager configuration file, so you have that as a reference point. But feel free to reach out to me if you have any questions, or you're watching this on replay and you have questions. Reach out. I am happy to answer them. Tom at Advanced Data Tools. So thank you all very much for being on the webcast. Lester, anything you want to add?
No, I think we're all good, Tom. Great job. Thank you very much.
Thank you.
Have a good day, everybody. Bye now.